Hello YouTube, this is Chesker from APKs. Welcome to another tutorial. In the last tutorial, as you remember, I had some issues with getting my file going, and this is what the problem was. So you know, I had created a folder, this gel folder. I had put it by mistake. I added it to OpenCV when in reality it should have been inside the scientific next to OCR, because if we look at the drop down, that's what they are, right? So I just put it in instead of, I created basically another drop down instead of just creating part of the scientific imaging. So you know, so now it's working. And now, before we get into it, there's an area that I wanted to talk about because this is from the Rice University. It's a pretty good page. It gets into some microscopy and some cool stuff. If you want to learn a little bit more of the analysis of protein gels, SDS page, and so on. And what I like about it is not only they really get into how to prepare it, they have a lot of nice how to load it, how to assemble it, what to do, but they also get into explaining what a gel, the qualitative analysis of a gel. And they explain, sometimes you have bands that are really close to one another, why that happens. So they call them doublets. And also, sometimes you're gonna see bands that look like this. And I'll show you some when we started working with some of the gels. And what what according to the author, he talks about these are caused by hydrophobic regions of the non or non-protein substituents. When he's talking about hydrophobic regions, what does he mean by that? For example, if you look into this is what a protein looks like, right? It has the pockets and it's got but this is a better representation. So you're going to have these regions. This pocket right here is this pocket right there. So but now with 3D, you're able to visualize it better. When he's talking about a hydrophobic regions, there are some amino acids, as you can see here. This is the chain of amino acids for these particular proteins, the crystalline structure of YBX1. And you're going to see some amino acids are rings, aromatic rings from, remember your days from your organic chemistry days. And some of them are just linear, right? So, for example, we know from biology that some hydrophobic, some aromatic rings, amino acids, for example, this I think this tyrosine, no, phenylalanine, this is tyrosine, and this guy is the tryptophan. So, and if you is here W, if you choose it here, it will show you where to find the tryptophan. It's right there. And sometimes here, if you want to find phenylalanine, you go there and it will find it for you. But that's what we're doing. So some regions are hydrophobic because they repel water, and this is what he's talking about, a hydrophobic region, because it's surrounded by many phenylalanine, tyrosines, and tryptophan. And what happens is that according to him, it creates these bands. I never knew that. I just learned that. So that's interesting. So sometimes you're gonna see some that has sharp edges, and some of them are gonna be that look like that. And how are we gonna deal with them? We're gonna deal with them in our code. But before we get there, let's not get ahead of myself here. This is what the types file with all the types, excuse me, with all the types. And it has It's got the detect bands, arrays, what is going to be using the booleans, basically making TypeScript happy. Then it's gonna go into the Canvas utils helper file. It's a very important file because this file is going to be the one that allows you to create the selections, dimensions of your rectangle as you click, as you make the rectangle. We saw that in the other tutorial. This is just from the other tutorial. We're just creating the temporary canvas. It creates a temporary invisible canvas, and it just copies the parts of it that we want to concentrate on instead of the whole image. And it just lets you process that particular section instead of concentrating on the whole image. Then it returns the temporary canvas for further processing. That's what that's doing. Next file, we get into the image processing file, which is this part right here. It will ask you, you have the option to click or not click these three boxes here. If you click, you will enhance the contrast. If you click, you will apply denoising. And if you click, it will use the O2 thresholding algorithm. Remember from the other tutorials. So that's basically what is this logic. This is coming from here. So when you click, it applies the equalize histogram function from computer vision CV, OpenCV. If you click denoising, it will apply Gaussian blur. But before it does that, it creates a black and a grayscale image. It takes a color image and it goes into grayscale. They always do that most of the time because it's easier to work with grayscale images than binary images. And here is going to create the binary image. It's OpenCV matrix. And then if you click, it will use the O2 algorithm. But if you don't click, it will go into the default and it will apply this algorithm instead. After it does all that, then it applies more morphological filters of erosion, dilation to clean it up, to make the look a lot better. And that's what's happening there. So basically, it makes the bands more defined. And don't be afraid to play with this because you can change them. You can apply more dilation. You can apply more erosion. If the bands are not connecting, this is where if you're having a gel that is giving you some bands that have spacings and stuff, this is you can erode, you can dilate. But don't be afraid to add more or to take out. Then it gets into the gel analysis. This is where all the magic is happening here. Because basically it's finding your ruler. And what do I mean by that? When you make a measurement with a ruler, you look at the ruler and the first thing you look at, is it a centimeter ruler? If you're in the United States, is it using inches? Is it using centimeters? So that's the first thing you do. You look at the spacings and you see, oh, it's an inch. Oh, it's a centimeter. Oh, it's a millimeter, right? So this is exactly what it's doing here. It's finding that ruler and basically it's looking for this ruler right here because it's telling it let's go back to our code here because if we go here, every gel is going to have what is called a range for that particular type of gel, right? So you're gonna have 14 to 70,000 for that one. You're gonna have 30,000 to 200,000, and so on. And you have calibration standards for that gel, and this is where these are coming from. This is where these are coming from because they know that that particular protein, wherever standard is using, he knows that it's 66,000. He knows that at that particular level is 45,000 from the top, is 36,000, and so on. That's where these numbers are coming from. So we gotta let the code know what these standards are. And for example, here they are. So that's one set for some gels. These are one for another set of gels. Like the one that he's using here is similar to this one, 66, 45, 36. So this is what you see here. 66, 45, 29, 20, 14, right? So there they are. So that's what's happening. So those numbers, you can change them. You can comment it out. You can, if you're using this particular gel for most of your applications, you just enter your marker setting here. So it's completely optional. You can change them to your heart's content depending on what gel you're using. So that's what's happening here. So basically, to recap, this function we're finding a ruler, what the spacings mean, and you have the power to change the intensity values by just changing the number, increasing the number, decreasing the number. You can change the spacings. You're in control here. You determine how long a band should be. These numbers are completely arbitrary. You can change them to your to fit your application. Same thing with the scores, because it's going to score the bands and it's going to pick the best one according to the marker set, correct? So you choose what the intensity should be. You can make it more sensitive, less sensitive, and this you can do it here, or I gave you an option here to do it through the threshold. So you can also make it more sensitive, or you can use the resize factor to make it more sensitive, less sensitive, and so on. So that's what's happening here. Um, okay, we continue. Basically, what's happening here is just a sorted algorithm. It's just it chooses the once it finds the number, let's say it's 67. What it's going to do is going to apply a sort algorithm, and it's going to look in the position of the range. So it's going to go here. If you're using this one, it's going to go through all of them, and then it's going to find that the range for 67 falls between 97 and 66, for example. It's just an example. And it will do it for each one. It's just a sort algorithm that we know from programming. That's all it's doing. So don't it's not as complicated as it looks. I mean, I thought about working with AI to make just feed it particular standards through AI. You can do that, and you can incorporate it with. But that's a whole different tutorial. But that would be a cool tutorial because you can actually feed it with different rulers or different measurement calibration bands. And how is it doing the calculation? All it's doing is using this curve uh, bands here. This is what standard curve, and it's determining through interpolation what if where it falls, and this is where the numbers are coming from in the under the hood. So you know when it says 205, 207, he knows that it fell through here because you know what myosin is supposed to be at that particular. Uh, you know that myosin should be that. So you know that if it's here, it's is you know it's that one, right? Because you know you have the calibration standard for each one. So that's where those numbers are coming from. So we continue. This is a lot very important uh, file there. Then we get into the visualization. Nothing new. It's just the same stuff that we've done in other tutorials. If you haven't watched it, go back to my other tutorials. I go more in depth into creating the rectangle, dragging, click and dragging, creating all of that. Here is the generate analysis text. All it's doing is you are in control of this. This is basically this is what's happening here. when it actually let's try ours. We got it ready, so might as well use it. So now let's create an area. I'm including the numbers for a reason. Let's do process selection. And there it is. If you're not using O2, right? It's going to give you more noise a lot because it's using the default. So once you go here, you use O2 and then process the selection, you see that it changes, right? So that's what's happening here. Um, Actually, this is OCR analysis. I was wondering, I'm going like, what's going on here? That's the OCR analysis. That's not the one that I wanted. It's this guy. And then we do choose file, same thing, same ladder, and then choose the area. You're not going to see the OCR applied now, but you still see O2 there. Process the selection, and now it's creating the bands, right? And this is the summary that I was telling you about. So it detected 7 bands and is getting, this is using, by the way, I don't know which one. Let's see what scale is it using, marker set. And you have to play with this to make it fit whatever you want it to fit, right? So in this case, it's using 97. Yeah, it's about right because it's detecting something. So it's over 97, so over 197 also, over 106. Yeah. But you can, it's not going to be exact until you make it work however you want it. You can, these are just proof of concept. I did not play with these numbers. This is just to show you how it works. To make it work really well defined, you have to play with the numbers. But it doesn't do bad. I mean, it could be worse. So it chooses the ones for each one. For example, 66. Yeah, that's about, yeah, lane two. I mean, it's not perfect, but it needs to be optimized, but you can play with those numbers. So that's what's happening in that particular file. So now we go into the next one. And this is the big one because this one takes all of the files that we've done. These, remember the references to the DOM, the threshold controls for the initial values. This is, if you want to make it more optimized, you can change those here. This is where you will change them to make them more optimized. This is taking the image upload. This we've done a million times in the other tutorials, so I'm not going to go repeating myself because you already seen it. If you haven't seen it, watch my other previous tutorials because this is what's going on here. And then applying OpenCV on it, and nothing that you haven't seen. It's just detecting lanes, but before we were detecting other stuff, OCR, we were detecting, but it's the same logic and same algorithms. Here is where the calculating the molecular weight. Is all it's doing is standard curve that I talked about here. This is the math beyond under the hood. This is where it's going on, and it's calculating. And here is the validation to make sure. So we've done it a million times, so you know. And now it goes into processing and the rendering. And these have been the same all along. And that's what's happening here. And this is where the containers look the way they look, like here. Okay. And that's it for gel electrophoresis. This one, we're going to use some of the logic for gel electrophoresis for Western blot because Western blot, the first step of Western blot is gel electrophoresis. That's why I'm doing gel electrophoresis first, and then we'll go into Western blot in the next tutorial. Well, this is the end of this tutorial. If you like this tutorial, please click the like box and subscribe to my channel. I will see you next time. Thank you for watching.